Hi friends, welcome to my channel. Let's have a look at the newly appeared problem. Problem 2428, maximum sum of an hourglass. In this video, we're going to practice the sliding window technique, which is actually very standard or routine. First, I'll read through the statement, and then we do a simple analysis, and finally we share the code. We are given an m by n integer matrix called grid, so we define an hourglass as a part of the matrix with the following form. So in other words, it contains 8 elements in this shape. So we are required to return the maximum sum of the elements of an hourglass. So here, note that an hourglass cannot be rotated and must be entirely contained within the matrix. So with that said, let's look at the two examples. In example 1, so because the matrix is 3 by 3, so there's only one hourglass. So it's corresponding to the 9 numbers except 4 and 6. So if we add 1 from 1 up to 2 up to 9, so in other words, sum 1, 2 up to 9, so we're going to get a sum that is 45. And then if we minus 4 minus 6, so we're going to get 35. So this is the output for example 2. So for example 1, so the matrix has size 4 by 4. So the sunglass patch is a 3 by 3 patch if we do not ignore the two, if we include that 2 elements in the middle row. And then, so this grid will produce 4 sunglasses. So here is one top left, then top right, and bottom left, bottom right. So if we compare all their sums, and then we are going to get 30. So this is the main statement. So here are some constraints. Basically, they said that so the size or the number of rows and columns are bounded above by 150. So and bounded below by 3. So this is actually the lower bound is an consistency assumption. So the last constraint is on the range of elements in the array, in the grid. So with that said, let's look at the analysis. So this problem, in some sense, is very routine. So we're going to use sliding window here. So the idea is that we could get each 3 by 3 block sum, and then minus the end element at the middle row of the block. Then we just need to do comparisons, right? So here is a note that may be useful. So actually this kind of problem is not new. So if we have implemented some neural networks, for example, convolutional neural networks. So here, assume the matrix grid dimension is m by m, and then the number of patches of size k by k. So in this problem, k is 3. So it's nothing but the product of m minus k plus 1 and times itself or its square. So if we consider the general case with a patch of size r by c, then the number is nothing but m minus r plus 1 times n minus c plus 1. So in these numbers, so the plus 1 is important. For example, if we have a 3 by 4 matrix, so ignore the last row, then we're going to have 2 patches, because n minus 3 plus 1 is 4 minus 3 plus 1, that is 2. So with that said, actually we can look at the code. So here first I'm going to introduce a variable called k, which is 3. So this is actually not necessary at all, but we introduce it in order that we put this problem in the general case. With that done, so let's get m and n, the number of rows and columns, just for convenience. So that will be length of grid and grid 0. And then with that side, so we're going to initialize a result variable. So this is used for comparison. So here we can initialize the result to be negative infinity, because later we want to find the maximal. But 0 is also okay, because here the grid elements have lower bound 0. So then with that said, we're going to do sliding window. So for doing sliding window here, so we know the size we are going to have this number of patches or equivalently sunglasses. So we want to use this iteration. So this is actually very simple. So for I in range, so m minus k plus 1. For j in range, n minus k plus 1. Oh, let's point out this m and n in general are not the same, so it's not a square. So it's m minus k plus 1 times n minus k plus 1. So this is a correction. So with that said, let's look at the code. So now we're going to compute a sunglass sum. So let's initialize a temporary variable called s, which is 0 at first. And then we're going to include several rows. And then for row index in range, so we're going to include 3 rows. So starting from I, so we're going to have I plus 3 because we want to have 3 rows. So in other words, the row index will be I plus 1, and I plus 2. Then S is incremented by the sum of grid, row index, and the column index will be J to J plus 3. So again, 3 columns. So this way actually computed the sum of non-elements. We want to adjust by minus the 2 nth element in the middle row. So that is minus the grid of I plus 1, so J, and grid I plus 1 and J plus 2. Right. So after this update, so we're going to have a sunglass element sum. Then what we're going to do is to compare this sum S with the result and pick the larger one. That is result equals max result and S. So then after the sliding window, we're going to return the final state of this result variable. So this finishes the sliding window procedure and the code format for this problem. So let's first do a special case check. Yeah, it passes the first example. Now let's look at the second example. So second example actually is very special. So we're going to return 35. Yeah, that's it. So now let's look at the generic case. Yeah, it passes all the generic cases. So I guess for this problem, this is actually a sort of routine problem. So here we use the sliding window, and in this implementation, I would say there are some redundancy in check for the current sum because we used, so each of the sliding window there are some common elements. But for this problem with the problem size, so given by the constraint item 3, so this will be fun, right? So with that said, I guess that's about it for this video. Thank you.